49 commercial drones falling from the sky in a single electromagnetic pulse, generated by a defense system named after a Spartan king. The US military spent up to $2 million per shot to intercept commercial drones costing only a few $100s in production. Most assume directed energy means lasers, but the actual breakthrough was an electromagnetic field disabling entire drone swarms simultaneously. This documentary explains how the Epirus Leonidas inverted the cost equation of modern drone warfare in a single electromagnetic pulse. Epirus is a California neoprime defense company founded in 2018 to deliver software-defined, directed energy systems at industrial scale. The company raised over $550 million in venture funding to hyperscale Leonidas production for the US military. Leonidas takes its name from the Spartan king who held off the entire Persian army with 300 soldiers at the pass of Thermopylae. The Leonidas name was deliberately chosen by Epirus because the marketing team apparently did not want a defense product called a microwave oven. The system generates high-power microwave energy that overloads the electronic systems of any drone flying into the electromagnetic field. The Pentagon officially classifies this approach as one-to-many, meaning a single pulse disables an entire drone swarm at the same instant. Traditional missile interceptors cost up to $2 million per shot to neutralize commercial drones, costing only a few $100s in production. Leonidas neutralizes the same drones at less than 1 cent per kill, a cost ratio the missile lobby probably finds deeply offensive. Leonidas requires zero ammunition and produces no kinetic debris, operating from a software-defined power management architecture. First operational delivery to the United States Army occurred in May 2024, with 4 IFPC HPM systems sent to the field. Those 4 operational systems deployed to the Middle East theater and the Indo-Pacific region within 12 months of Army acceptance testing. Leonidas is built on gallium nitride semiconductors, the same compound powering high-frequency 5G networks and electric vehicle inverters. The antenna is an active electronically scanned array rather than a dish, allowing the beam to steer without any mechanical rotation. Beam steering allows Leonidas to track multiple drone targets independently across a wide engagement arc, all inside a single pulse window. Earlier microwave weapons fired 10 nanosecond pulses, but Leonidas extends each pulse to a full millisecond for sustained electromagnetic effect. The pulse duration extends 100,000 times longer than older microwave systems, completely changing how the energy disrupts drone electronics. Drone electronics inside that electromagnetic field experience cumulative voltage overload, which is a polite engineering term for catastrophic instant death. The software-defined waveforms allow operators to tailor each pulse to specific drone signatures without changing any hardware on the existing system. This is how Leonidas gets progressively smarter with every engagement, because every drone signature defeated adds to the waveform optimization database. Range expanded from 1 kilometer in Generation 1 to over 2 kilometers in Generation 2, without changing the antenna form factor. The power output increased a full 30% in Generation 2 through firmware optimization of the gallium nitride amplifier array alone. Laser systems engage only one drone at a time and need long dwell to burn through. Plus, they degrade significantly in poor weather. Radio frequency jammers cut the command link between operator and drone, but cannot stop autonomous or fiber optic guided drone systems. Leonidas does not care about the control link at all, because it destroys the onboard electronics directly through induced voltage in the circuits. In January 2026, Leonidas defeated a fiber optic drone for the first time, a problem competitors had called fundamentally unsolvable. That single live-fire test closed the most dangerous capability gap in modern Western counter-drone defense across every battlefield environment. To understand exactly how a 1 cent pulse defeats a $1 million threat, subscribe now before this section breaks down the contract math. In January 2023, the U.S. Army awarded Epirus $66 million through the Rapid Capabilities and Critical Technologies Office Program. 4 IFPC HPM Generation 1 systems delivered to the Army in May 2024, with field deployment to operational theaters by year-end. The 4 prototype units deployed to the Middle East in 2024 and then to the Indo-Pacific region during spring 2025. The Pentagon paid less for the entire Leonidas prototype contract than the unit cost of one F-35, a deeply unflattering industry comparison. In July 2025, the Army awarded Epirus a follow-on contract worth $43 million for Generation 2 systems. Generation 2 testing ran at Naval Air Weapons Station China Lake in October 2025 against multi-vector drone swarm scenarios. Leonidas dropped 49 quadcopters in a single pulse, the largest drone swarm ever publicly confirmed in any directed energy program. The Air Force is expected to begin leasing IFPC HPM systems in 2026 for the urgent point defense of bases and flight lines. The Marine Corps acquired 2 Leonidas systems, with the Navy and Joint Counter-UAS Office running demonstration programs in 2026. Leonidas now ships in 3 product variants covering fixed ground installations and mobile vehicle trailers, plus the airborne Leonidas pod platform. The Marine Corps variant, named XDEX for Expeditionary Directed Energy Counterswarm, is built for JLTV trailer integration. Epirus partnered with Digital Force Technologies to integrate the Seraphim C2 software for AI-driven detect to defeat kill chains. Leonidas integrates with FAADC2, the standard US and NATO command and control framework for counter-drone air defense networks. Epirus closed a $250 million Series D funding round in March 2025 to hyperscale Leonidas production capacity. Ukraine, Russia, Israel, and Iran reshaped drone warfare in 2024 and 2025 by using cheap commercial quadcopters as strategic strike weapons. Airfields and missile bases sustained catastrophic damage from drones that illegally entered their territory during covert swarm strikes. U.S. military bases reported drone incursions across multiple states in 2024 and 2025, including airspace over Langley Air Force Base. Every single intercept mission cost defense budgets thousands of times more than the unit price of the cheap intruding commercial drone hardware. Leonidas reverses that math entirely, because the per-pulse cost is just electrical power, and the system magazine remains effectively unlimited. A Leonidas unit runs for 30 minutes without external power, using onboard batteries at full combat output during the engagement window. Operators define safe zones around friendly assets, so the electromagnetic field does not damage Allied electronics inside the kill envelope. The Pentagon classifies Leonidas as non-kinetic, meaning no debris and no ballistic risk to civilian populations below the engagement footprint. Australia joined the Leonidas program through AUKUS Pillar 2, integrating the system into Project Land 156 for counter-drone defense. International export of Leonidas became possible only in 2025, after multi-year restrictions on directed energy technology transfer were lifted. Allied buyers across AUKUS, the Middle East, and select NATO members are queuing for short-range air defense procurement. The original Leonidas held off Persia with 300 men, and the namesake holds off 49 drones in one pulse. The Leonidas branding is good, but the underlying engineering is exactly what generated the formal Army acquisition decision in the first place. By 2026, Epirus had 200 employees in California and Washington offices, with production capacity over 100,000 square feet. Epirus delivered its first prototype 9 months after the initial contract, a velocity rate most defense companies measure in multiple years. Leonidas amplifier blocks called LRAMs swap in and out of the system without disassembly, allowing field repair under 1 hour. Hardware refresh happens through swapping standard line replaceable modules, but capability refresh happens through software updates over the network. Each firmware update brings waveform optimization, expanded threat libraries, and target discrimination across operational profiles. The Pentagon framed this approach as software-defined warfare, where the firmware version effectively functions as the new ammunition type. A Leonidas unit purchased in 2024 can engage 20-30 threats through firmware updates alone. No new hardware required for service life. Leonidas is the first counter-drone weapon designed around the strict assumption that the threat library will completely change every 2 years. Drone evolution moves faster than any procurement cycle ever built, and Leonidas was engineered for that exact pace of operational adaptation. Future variants target ground installation and vehicle integration, plus shipborne pods and fixed-wing aircraft mounts for distributed swarm coverage. The Golden Dome layered defense concept includes Leonidas as a primary inner layer for short-range counter-drone engagement during attacks. Kinetic interceptors remain useful against high-value individual targets, but volume threat requires non-kinetic field weapons like Leonidas. The cost imbalance in drone warfare is the defining problem of the decade. and Epirus solved it through software-defined microwaves. A neo-prime startup founded in 2018 reached operational deployment before legacy defense primes finished their directed energy feasibility studies. A Silicon Valley company fielded a working microwave weapon before the traditional aerospace giants even approved their PowerPoint slides on the concept. Leonidas is not the answer to every air defense problem, only to the specific volume problem defining modern asymmetric drone conflict. The next platform on this channel does not destroy the drone, but becomes the drone itself, and the conventional definitions stop applying entirely.